Welcome back to the ELM test series by James S. That's me. This is part 34. We're looking at adding and subtracting fractions once again. As a review, let's look at two basic fractions, 2/3 plus 3/3. We'll make it easy on ourselves. You can think of the bottom, the denominator, as the name if you want. Nickel, dime, quarter, box, cube, John, Frank, lemon, orange, whatever. This is be more or less the name. I've got 2 of those plus 3 of those for a total of 5 of those 3's, or 5/3. I have 2/3 plus 3/3. That's why we don't add the bottoms. But the thing we do have to have is we have to have the denominator be the same. Otherwise, we're adding apples and oranges, or nickels and quarters, or whatever. But we want to add apples and apples and oranges to know how many we have. Well, if I said I had 2 oranges and 3 apples, well, that's all I'd have. I'd have 2 oranges and 3 apples. Unless I could somehow get the denominators to be the same. And of course, that's one of the things that troubles us with fractions. And I need to take this off because that problem no longer exists. So let's look at the idea here. I want these to be some common denominator. Well, if it's a number, these are both prime, so there's nothing in common between them, so all I can do is multiply the 2 of them together. So if I multiply 3 times 5, I get 15. So now my name has changed. Well, I need to change both of these to the same amount. So to make the 3 of 15, I'm going to multiply by 5, top and bottom. I multiply by 5 over 5 because that's essentially just 1. That's just another value for 1. And 1 times anything is still just itself. Over here, I'm going to multiply by 3 over 3. Again, the 3 over 3 is 1. So 5 times 2 is going to be 10, and 3 times 3 will be 9, and I'm still adding. So now these are both 15, 5 times 3 and 3 times 5, and so the bottoms are both the same. Now I'm back to apples and apples. Well, I have 10 of these plus 9 of these for a total of 19 of these, or 19/15ths. So the idea of adding or subtracting, it doesn't matter whether I was adding or subtracting here, nice subtraction. The same rule applies. I have to have the same thing. I can't add apples and oranges. So the question then becomes, how complicated can this get? Well, it might be simple as 2 over 3a plus 3 over 2. I'll just say 3 over 2. Well, again, this could have been negative, it wouldn't matter. But right off the bat, I see that my names are different, and I need the same thing. Well, I look at this, and I see this is a 3 and this is a 2. They're both prime, so I could make them both, turn them both into 6's, multiplying this by 2 and this by 3. Okay, that covers the number. But what about this letter? I have an A here, but I do not have an A here. So I also have to multiply by A. 3a times 2 is going to be 6a. 2 times 3a is going to be 6a. So now I have the same thing. Well, I multiplied the bottom by 3a, so I must multiply the top by 3a. I multiplied the bottom here by 2, so I'm going to multiply the top by 2. Alright, so I said that my bottom was 6a, so I'm going to put my bottom over here. And then I'm going to go ahead and multiply the tops. 2 times 2 is 4. 3 times 3a, 3 times 3 is 9. A times a is 9 times a. Now you notice here that my tops are not the same. So the most I can do is just say 4 plus 9a. There's nothing I can do to combine numbers with letters. Again, up on top I have apples and oranges. Well, I swapped my apples and oranges down here on the bottom, so I had the same thing, but up top I've got two different things. I can't add numbers and letters. The only way I'd be able to add these is if this were also an A, but it is not. So all I can say is it's this quantity over 6A. Well, I added the fractions and I have an answer. Well, let's make it a little more complicated. I'm running a little low on ink there. Let's try this one. There we go. Well, what the heck. We'll make this a minus this time, just to make it a little different. Okay, we are adding or subtracting, so when we add or subtract, we have to have the same denominator. Well, this looks a little more complicated here, James. So what am I going to do? Well, there's nothing in common here, so I'm just going to consider each of these a quantity and multiply them. Well, if you remember, when we multiply, putting fractions around or parentheses around these two, I will multiply this times everything inside here. So 3 times a will be 3 times a, plus 3 times 2 is 6. Now I have my new denominator. Well, I multiplied this by a plus 2, and I multiplied this by 3. Okay, so this is now 3 times a plus 2. This is 3 times a plus 2. I could have just left it as that for my denominator, but I'll tell you what. I'm just going to leave it as that. 3 times a plus 2. Now understand that if you have an answer that doesn't look like that, they may have distributed and said this is 3a plus 6. So you could leave it like that, but your answer on the test might look like this. But if you don't see that, you say, oh, I'll just distribute that because that's what they did. Now, if you see that, you may not necessarily recognize that as being distributed. So you want to go back and look at what you did over here and say, well, what if I distributed, there's only one parenthesis, and here I had 2. So if I combine these, yeah, it looks like I can get that. All right, so I'm good to go there. Well, I multiplied this side by 3 on the bottom, so I'm going to multiply by 3 on top. I multiplied on the bottom by a plus 2. So on the top, I'm going to multiply by a plus 2. My result on top over here, 3 times 3 is 9. I've got a minus between them, and I've got 5 times a plus 2. All right, so my final answer on top is just 9 minus 5 times a plus 2 all over 3 times a plus 2. Now do not make the mistake of saying, oh, well, these will cancel out, because they won't. If I'm going to cancel anything out of this term and this term, I have to also cancel it out of this term. Anytime I remove something from one term, I must remove it from all the terms if they're all associated like this. So again, my answer might have distributed the 5 in there, and then I would have had minus quantity 5a plus 10. Now remember to distribute this 5, or this negative, through each of those terms. So I'd have 9 minus 5a minus 10 all over, and I'll just combine it, 3a plus 6. Well, there again, I've got a little work to do. I could combine those. 9 take away 10 would be minus 1. So my final answer on this, and it's getting a real busy here, This kind of problem is going to take you a little time, so you might want to, if you don't see it right off, you might want to skip it and come back to it. So the final answer is minus 1 minus 5a all over 3a minus or plus 6. Sorry about that. All right, just combining the 9 and the 10 for a minus 1, bringing the minus 5a up. All right, so if I were doing a problem like this, and I'm looking at several answers down below, the easy part is looking at for the denominator. Well, the first thing I'm going to do is I'm going to look down through all the denominators, and anything that does not look like that, or does not look like 3 times a plus 2, I'm going to throw those away. And that usually cut down anywhere from 2 to 3 answers. Now I might be able to look at the top and see something obvious. Let's go back here just a little bit if I can remember what this is. Okay. I had a plus 2 here and 3 here, and a minus, and I think I had a 3 here and a 5 here. Well, you remember when we multiplied this side by a plus 2 to make it common, and this side by 3? Well, you notice that I also multiplied the top by a plus 2. Actually, what I did is I took this amount and multiplied it over there. There it is. I took this amount and multiplied it over there, and there it is. So I could get my tops simply by cross multiplying my bottoms. So I would take this number times this, I would take this quantity times this, so 3 times 3, and a plus 2 times 5. And now I might be able to recognize, if I got this down to 2 answers that had the same denominator, I might recognize, oh, well, I have 9 here, I've got a subtraction here, but I can see a 5a. If one of the answers does not have a minus 5a somewhere in it, regardless of what else it has, if it doesn't have that, then I'm going to throw that away. So there's little tricks that you might use to not have to do all of the multiplication to get your answer. You can do part of it, get close enough and say, oh yeah, this one doesn't have what I need. All right, so let's look at, and we're well over our time here, so I'm going to have to revisit this again with adding and subtracting fractions, or we will say complex fractions, maybe. All right, so hope that was helpful. Have a good day.